small. Yeah.
Of course, Newton's third law. So
Yeah.
N1 acting on different objects equal and opposite.
And I've got an A.
M into A. Let's see.
Yeah.
So okay, so Shaurya, tell me forces acting on capital M.
The weight is acting downwards and the normal reaction is upward.
Fine. So in this question, Shaurya, the normal reaction and the weight will balance out. So
Hmm.
we can just ignore it. Anyways, they are balancing out. Right. So what do we do now? You need to just
So
use the
we just
Newton's
so
second law.
it's yeah it should be B, right, because we just use a Newton's second law. It will be
Yes.
capital MA. So F net will be equal to capital MA, which will be equal to
Okay. So Parth, let's start with M. Tell me the net force acting on small m.
it'll be F minus N1,
F minus N1 will be equal to what?
small MA.
Small ma. And now tell me the net force on capital M.
N1 is equal to capital MA.
That's it. Now,
So we
since the
know that N1
question,
and N1 are equal, so it'll just be capital MA.
correct, we want the force that the block of mass is exerting on the block of another mass, that is N1 only. So Ma is the answer. Shaurya, check.
Oh, okay.
This was your doubt, Saksham. Is
What
it
okay.
clear?
Yeah, I got this wrong. Yeah.
Okay. Saksham, did you go through this file yesterday?
I did go through this file. Yeah. It was the wait, I think it was Newton's third law or something like that, or momentum.
So,
I
Saksham, which
remember.
means, is it, I mean, I have placed the text solution there.
Yeah, I
Is
went through
it
the text
clear or clear
solution
not
also.
enough?
Yeah. It's here.
But
Okay.
I get it. Sometimes, next time onwards, I'll put everything in video format so that you can revise whenever you want. And Shaurya, check.
Yeah, sir. I think this is clear.
So which option?
Option B.
Correct. So moving on, next. Sixth, seventh. So Shaurya, next time, and in fact, this is an instruction for all of you. Do not start solving questions from either of those websites, Exammate or Revision Village, before you have completed revision from my notes. See, I have tried to create very concise, detailed, clear notes. First finish that and then only come here.
Yes, sir.
Okay.
Otherwise, unnecessarily, you will feel difficulties.
Wait,
Shaurya,
what's the first website?
the no, Exammate. So, Saksham, both of those
Exam.
websites are on the group description.
Yeah, Revision Village, I know. I
Yes.
just didn't go to the exam mate.
So, first go through the my notes and then only if you have time, get into here. Okay, next. All right. Next question is this. Everyone, please read and solve.
So this question was there in a like summative also, but I just forgot like the approach to do the graph
Okay.
analysis for such questions.
One second. Let me
What's the
put up.
option? Yeah.
Okay, one second. Where do I put the graphs? Now you can see. Acceleration versus time is given. We need to figure out variation of velocity with time.
So the answer should be A, right?
So the answer
Is
in this case might be V. I think.
option
No.
B.
It will be A. It will be A.
Okay, let's start with you, Saksham. Why A?
So because like there's zero acceleration, right? It's starting from zero acceleration and going
The
like
acceleration starts from zero.
yeah, it starts from zero. Yeah.
Let me write. Acceleration is zero at the starting point. Now what do you do?
Wait, no. Wait. It won't be A.
So,
Sorry. Just give me 2 seconds.
so should I tell you why it's here?
Yes, Parth, tell me.
Because the first acceleration is happening at a constant rate, so there'll be like an exponential kind of graph made at the beginning.
Okay.
So we can see that then acceleration will start to like slow down and get towards zero. So therefore, velocity at that point will be constant, and then we'll have it decreasing. So it will be like more of like a curve towards the right. That's why it should be A.
Fine. That approach is correct, but let's use an even easier approach. So, Parth, tell me, if you have a velocity time graph, how do we get acceleration from that?
If you have a velocity time graph,
Hmm.
the gradient.
Yes, or the slope, right?
Yeah.
So at t is equal to 0, acceleration is equal to 0, which means the slope of the velocity time graph should be 0 at the starting stage. Now, when the slope is 0, that implies the graph is horizontal. It's a horizontal straight line. Now look at option A and option C. In both these cases, the gradient at the start will be 0 because the tangent will go parallel to the x-axis. Check. Is it making sense?
Yeah, so
Arman,
Yes.
slope is nothing but the tangent ka slope. So horizontal straight lines ka slope is 0. And now Parth, what do we do? Option B and D are eliminated straight away.
Yeah.
Now, how do you select one out of A and C?
So you know that the velocity is increasing at the start, so it can't be C.
Where is it
Velo-
mentioned? Velocity is increasing.
So acceleration is increasing, so velocity will also naturally increase.
No, doesn't matter. So, okay, Parth, imagine a object moving left, but the acceleration is right. In that case, velocity will decrease. Can you
Okay.
visualize, Parth? If velocity, acceleration, directions are opposite. So ignore that. Let's try to use a simpler approach. So think, how do we eliminate one out of A and C? It is tricky indeed. Check Arman, you as well.
I don't know if it's the same method, but if A is positive, then the slope is positive, and it's the same thing only.
Okay, no, there is one more way. See the basic approach. Okay, so Arman, again, same question. Velocity time ka slope or gradient gives us acceleration, right? Arman?
Yes, sir. Yes, sir.
Okay, now this will be maths, a bit of basic maths. So tell me this. If I draw a graph like this, let me label A. Let's say this is A, this is B. And by the way, all of this is in the first chapter ka notes. A, B, and then C, and then D. Okay, so let me start with Parth. So Parth, look at graph A. Is the gradient positive or negative in A?
Positive.
Positive, so
It is positive, but is the gradient increasing or decreasing for A?
it's increasing.
Increasing.
Yes. So for A, let me write down the gradient is increasing.
Non-linear is positive, right? Positive non-linear, something like that.
Correct. In B, Parth, same question. What is happening to gradient?
The gradient is decreasing.
Okay, let me write down your deductions, then we'll discuss. For C, Parth.
Oh, C, the gradient is also decreasing.
Okay. For D,
Gradient is increasing.
let's
So in
analyze
B,
it.
it will be increasing, no? Gradient is increasing because it's still over there, it's just reaching a plateau, but it's still increasing till that point.
Let's think. This is from maths. So, Shaurya, Aryaman, you
Oh
as
wait,
well.
no. In C, the gradient is increasing because it's going negative now. So in C, the gradient is increasing, but in D, the gradient is decreasing.
Okay. Aryaman, what about you?
no,
Not
I
bad.
think what this is correct over here.
Okay, fine. If this is correct, now let's come back to the question. So now, Shaurya, let's start with you only. If I consider, let's say, let me consider option C first. If you consider this part of the graph, is the gradient increasing or decreasing?
It's increasing.
Okay. And what about this?
There it's decreasing.
So which means it is satisfying this thing. Because
Oh.
what is this? Acceleration is nothing but gradient. So our gradient first should be increasing and then it should be decreasing. So we need to check where in A and C is that happening.
So no, sir. So here it's going negative now, gradient. So here it will be the opposite. Because our gradient is a negative, right?
Okay, hang on. Path. According to this, acceleration is increasing